Okay, so here's the next one I want to take a look at. So this is something, I'm not 100% sure how to pronounce this name correctly, but I think this is called the Delaunay mesh. And how would you describe this graph?
It's
a little better on screen.
Two-dimensional, but it looks like everybody has different amounts of connections, and also like sort of the length of the lines connecting people are different. So it's like maybe points were randomly chosen inside a circle, and then the connections were also randomly chosen between a certain number of connections.
Okay. Interesting. So let's see what our average number of connections seems to be, right around 6 here.
Okay, so it's the same as the 3D model.
It's definitely more varied, though.
Oh, yeah, that's a good point. There's actually a distribution of connections.
Like there's, as low as 4, as high as 10.
Well, even a few have under 4, but yeah. So there's a distribution. So what do you think about how an infection might spread through this network? Here's the first. We'll show the first 5 steps again. Well, actually, before I even do that, what do you think? Do you think it'll spread slower, faster, about the same as our grid graphs?
I think it'll actually matter where you start with the starting number of the first person to get infected, how many connections they have. That might make a difference. Like if the first few people to get infected have like 2 or 3 connections, it's going to spread fairly slowly, just from the first few cases.
What do you think?
I think the rate is going to be really varied from the start to the end. Like it won't be a sort of constant up and then a constant decrease.
Oh, okay. That's interesting.
It'll probably look different every time you run it.
Well, we can certainly do that. All right, so there's our 5 steps.
You've already infected a significant portion of the graph.
Yeah, and well, here's 30 steps.
This actually spreads pretty quickly.
It spreads quickly and then sort of tapers off pretty fast. It looks like it just sort of, it's not really stopping when it hits that.
Yeah, it's almost like a corner.
Yeah, it's interesting. You're right, it didn't bend over as much. But you thought this might look different for different times that we run it.
Yeah.
Okay, so this was a random disk, so let's run it again. Okay. Same kind of different.
About 5.9 connections.
Okay, here's our spread with 5.
It looks like a little more this time that we're covering.
Okay, and then in our spread through the graph, I got to rerun this, but it was sort of in the beginning of the, maybe a third of the way over on the second line where we hit 1,000.
Yeah, it looks like it was a little slower this time.
Yeah, but not outrageously slower.
Yeah, I guess there's some variation, but there's not too much.
Okay, so, I know we've only run it twice. We'll run it one more time and see. So we thought it might vary a little bit by the graph.
So now you're not starting on the edge, so this might be different.
Okay.
Yeah.
Hit it slightly sooner, but not
not a whole lot.
Not a whole lot sooner. Although it does have that same sort of corner that you were talking about.
Yeah.
This is much less S-shaped and much more sort of just goes up. Although it's still underneath an exponential, interestingly, because you can. It's kind of straight, but anyway, it's sort of on the log graph. It's bending down, so it's underneath the exponential. Okay, interesting. All right, so now we'll go. To the next level.